This is 2019 Amc 10A questions. Okay, so each video contain about around 2 to 5 questions. Okay, so in this video we're gonna try 5 questions. Okay, number 1 to 5. Okay, the question is easy. Okay, just we go over, right, how to solve this one. Okay, now let's try number 1. What is the value of this one? Okay, you know that 0 to the 1, any value of k. Okay, maybe we 0 to the third power, 0 times 0 times 0, always 0. You know that, right? So this number 0 to the any power, always 0. Okay, this is 0. So we got what? 2 to the 0 plus another 2 to 0. 1 plus 1 is 2. Okay, yeah, this is easy questions. Okay, now number 2. What is the hundredth digit of 20 factorial minus 15 factorial? Okay, you know the factorial, right? So 20 factorial looks like this way. 20 factorial is 20 times, 19 times, 18 times, all the way down up to 2 times 1. That is 20 factorial. What is 15 factorial? 15 times 14, 13, and 2 times 1, right? We know that. Okay, but first we have to figure out 20 factorial and 50 factorial. Okay, there are a lot of what? 5 prime factor, 5 prime number 5, and 2. You know, there are a lot of 5s and 2s. Okay, first, if we have a 5, 1 5 and 1 2, it'll make like 10. Okay, if you have a 5 square of 2 square, it'll make 100, something like that. Okay, first we can check how many 5s are there. How many 5s? Check it out. 15. Okay, so 15, it has 5. Okay, 5 times 3, isn't it? Okay, I'm gonna write down 5 times 3. It is 5. 10, 5 times 2, right? We have another 5. 5 factorial. So in number 5 it has what? Another 5. Okay, and so there are what? 3 5, right? 3 5. And you can see there are so many 2's. Okay, first one is 14 is what? 2 times 7. All right, and 12 is what? 2 square times 3, isn't it? We have 2 squares. And also what? 10 is what? 2 times 5. Okay, there are many, right? It's enough. We have 3 5 over here. 5 times 5 times 5. But when you take a look over here, 2 is a lot, more than 3 times. Anyway, we need only 3. That's enough, right? Okay, so when you multiply this one, each one has what? 10, 10, 10, isn't it? So this number 15 factorial, this number 15 factorial, there's many numbers over here. They're gonna end with what? 30, right? That's it. Okay, now we continue. Okay, 20 factorial. We already 3 5 over here. Okay, 20 factorial is what is it? 20 factorial. And we'll write down. Okay, 20 factorial. So for this 20, we have a what? 1 5, isn't it? 5 times 4, right? We have a 1 5. So in 15s, 35. Okay, 35. So we have a 4 5, right? 5 times 5 times 5 times 5. But we know that there are many 2's, more than 4, right? So write down 2 times 2 times 2 times 2. So when you take a look up here, Each one is what? 10, 10, 10, 10, isn't it? So we can see 20 factorial. This 20 factorial and what? So some number and 4 0, right? Okay, and with a 4 0. 15 factorial and with 3 0. So when you subtract, what are you going to do? 0 minus 0 is what? 0. 0 minus 0 is 0. 0 minus 0 is 0. This one, we don't know. Okay, anyway, hundredth digit, right? This is hundredth digit, always 0. Okay, right? Choice A is the answer, okay? Here is number 3. Anna and Bonita were born on the same date in different years. Yeah, same date. I'm gonna make table, okay? This is Anna and Bonita. Same date, but n years apart. Okay, always what? Their difference is n years. Okay, so okay, last year, this is now. This is last year. Okay. So Anna is 5 times as old as Bonita, right? If Bonita is x, Anna is what? 5 times x. Okay. So this year, Anna's age is the square of Bonita's age. So Bonita this year is how much? Just one more add, okay? X plus 1. After 1 year, Anna is now 5x plus 1, isn't it? And also we have a constraint. 5x minus x. That is the difference, 4x, right? This is already n, is okay? Yep. Or from here, the difference still 4x. Okay, now let's apply this constraint. Now, okay, this year Anna's age is square of Bonita's age. Okay, so Anna's 5x plus 1. That equals, what is that? X plus 1 square, right? That's just 1 square, right? So 5x plus 1 equals x squared plus 2x plus 1, okay? So you can calculate this one. X squared minus 3x equals 0. X is out, x minus 3 equals 0, okay? X cannot be 0, isn't it? X cannot be 0, you know that. But the only thing is what? The only value of x is 3, okay? But they're asking you find the value of n, not 3, okay? The value of n is what? 4 times 3 is what? 12. Okay, so that's why we got 12. Number 4, a box contains 28 red, 20 green, 19 yellow, 13 blue, and 11 white, a lot. 11 white and 9 black. I'm going to use black. All right. So the question is, what is the minimum number of balls that must be drawn from the box without replacement, but we need guaranteed at least what? 15 balls of a single color, okay? That means what? 15 balls should be same color. Maybe you can use case 1, maybe you can think, oh, we have there are. Already 15 balls. Yeah, there are 15 red, it's okay. But 15 number, it doesn't guarantee, right? It doesn't guarantee. This is a very lucky case, right? This is very lucky. But it doesn't guarantee. Sometimes we have, right, different color, okay? So the point over here, always we have to think is worst case. We need to find the worst case. Okay, they are all different color, okay? All different color. So I'm gonna make a table, okay? Red, green, yellow, blue, white, and black, okay? So we have 12 8 red, 20 green, 19 yellow, 13 blue, 11 white, and 9 black. Okay, now check the worst case. Black is 9. If you got all 9 balls, 9, 9, 9, 9, 9, 9. Okay, this is the worst case. They are different balls. So if you take out 54 balls, still only 9 balls are same color. Okay, so when you take a 9 over here, this is not no more. This is out. Okay, now take the rest of them. We still have right 2 more white over here. Okay, 2 more white. So from here we take 2, 2, 2, 2. They are different colors. Okay, so that is what 10 balls out. It's okay, but this is no more. Right? The white is out. The next one. Take over here. This is 11. This is 2. So we need 2 more balls, right? Black. Okay, 2, 2, 2. All different colors. This is 8 balls. Okay. Now keep continue. So 13, okay, this is out. So from here, there is 13, right? We still have about 6, isn't it? But we need what? Okay, from here we got, let me see. From here up to here we got what? 13, same color, right? 13, same color. To get what 15, we need what 2 more, isn't it? So take 1 more. 1, 1, 1, right? That is what 3 balls out. Okay. Now we got what 14 up to here. You got the 14 balls. 14 balls out. 14 balls out. So when you choose then the next one, this ball or this ball or yellow, it's gonna be 15 balls, isn't it? So the next 1 balls, this guarantee there will be what? 15 same color balls. Okay, so we gotta count all these numbers. So that is 64, 72, 75, plus 1 is 76. Okay, so 76 balls will guarantee there will be what? 14 same color. Okay, so choice B is the answer. So this question's number 4. If you know this one, okay, the worst case. Okay, I'm gonna try this one again. Sorry. Okay. 28 red, 20 green, 19 yellow, 13 blue, 11 white, 9 black. So what is the worst case? If they are up to 14 balls, we can draw out. Okay, 14 balls. So take up 14 over here. Take up 14. Take up 14. Take up. Oh, this is not 14, right? Just we take more everything. 11, 13, 11, and 9. Okay. So what is the sum of all these balls? Take a look. This is 42, 20, 33. Okay, that is 75, isn't it? 75. 75 balls is out. So the next ball will guarantee, right? Because this is balls is out, this balls is out. The next one, this is black is out. The next one will be what? It can be red, green, or yellow. Okay, so 76 balls. Okay, 76 ball will guarantee there are 15 same color. Okay, guarantee 15 same color. Okay, you can solve this way. Okay. Alright, take a look number 5. What is the greatest number of consecutive integers whose sum is 45? Consecutive integers. Okay, increased by 1, right? Integer, not positive integer. Okay, this is not positive. It can be negative number too. So to have a 45, sum is 45 from 0. Negative 1, 1. That is 0, right? So we start negative 45 up to positive 45. When you add more, okay? When you add all this integers is going to be 0, isn't it? But the next number will be 46, but this is 45. That is not working, right? So we're going to start one. Negative 44, isn't it? This one is up to 44, right? Up to 44. I'm going to delete this one. Up to 44. The sum of this one is all 0. It's okay? So when you continue the next number, it's going to be 45. That is the sum of all these numbers. Okay? So this is like greatest number of like consecutive integers. Okay? How many integers are there? To the here to negative 1 to negative 44. 44 numbers. 1 to 45 is what? 45 numbers. 1 is what? 0 is one number. Okay? When you add more, this is how much? There will be 90 numbers. Okay? Or when you add all these 90 numbers, the sum is 45. Okay? So choice D is the answer. Okay? Okay, that's it today. Okay, so I'll see you next time. Okay, thank you. Bye bye.